Alright, students and fellow math geeks. Today we're going to talk a little bit about constant rate. Now, last week, or the last previous lesson, we started talking about distance formula. We talked a little bit about how distance equals rate times time. And therefore, to find the rate, you just divide both sides by time. So to find the rate, it's really distance divided by time. So we're going to be working with this a little bit as we move forward into this lesson. In today's lesson, though, we're going to be showing you the equation, the table, along with the graph dealing with the constant rate. So let's take a look at our first example. It says Pauline mows a lawn at a constant rate. Suppose she mows a 35 square foot lawn in 2.5 minutes. What area in square feet can she mow in 10 minutes? Okay, so we want to figure out what is the rate. So in order to find the rate, we're going to take the distance, or in this case, we're going to call it the area. So the area over time, so the amount she can cut over time equals our area. So we know that she can cut 35 square feet in 2.5 minutes, which simplified works out to be 14 foot per minute, 14 square feet per minute. Okay. So we now want to know, well, how much could she mow in 10 minutes? So again, let's use our proportions. Our known proportion is 35 over 2.5. Set that equal to what we don't know. Well, we know she does it in 10 minutes, so that goes on the bottom, but we don't know our distance or the area covered. So now go ahead and do your cross multiplication. So that's going to work out to be 2.5a times a equals 35 times 10, which works out to be 2.5a equals 350. Divide both sides by 2.5. The area she can cover in 10 minutes is 140 square feet. Okay, so now let's set up our equation to actually figure out in t minutes how much she can get as a relative term to distance. So again, set up our known equation, 35, do this over here, 35 over 2.5. So now we do not know the area. So in this case, we'll call it y like we did the other time. And we don't know the time, so we're going to put t. So do your cross multiplication. You get 2.5y equals 35t. So now divide both sides by 2.5. You get y equals 35 over 2.5 times t. And if you want to simplify that further, that is y equals 14 times t. So the significance of this equation is we can now figure out how much square feet she mows for any amount of time. So if I put 5 minutes in for t, it would be 14 times t, and that would tell me exactly how far she would mow. So now let's take a look at our table down here. And we're going to use the equation with y equals 14t. We'll get rid of the ratio there, make things a little bit easier. So now I want to figure out, okay, well, let's try it for 0 minutes, 1 minute, 2 minutes, 3 minutes, and 4 minutes. So go ahead and substitute in your letters in the middle. So it's going to be y equals 14 times 0. And 14 times 0 is 0. So for 1 minute, y equals 14 times 1. And 14 times 1 is 14. For 2 minutes, y equals 14 times 2. And 14 times 2 is 28. And continue on. I'm just going to go ahead and write. You guys can write as well. And finally, the last one. That's going to be 56. Okay, so there we've been able to complete a table, and one thing you can notice is see how the numbers are changing on our right side of our table. You notice how it is increasing by the same amount each time. It's increasing by 14 each time. So let's take a look at how that appears on a graph. So again, at 0 minutes, we get 0 square feet, because if you haven't mowed, you haven't cut any lawn there. So now let's take a look at 1 minute. 1 minute, we can do 14 square feet. So come on up here as best you can. Mark 14. At 2 minutes, so I'm over here at 2 minutes. It's going to be about 28, which is a little bit between 25 and 30. At 3 minutes, she does 42, so come on all the way up to 42, which is probably right around in there. 4 minutes, 56, a little bit right there. Okay, and at this time, don't connect the dots, just leave them there. Hopefully you can kind of see a little bit of a pattern, or not necessarily a pattern, but hopefully you can observe what the graph is looking like. That's something we're going to come back to in a little bit. All right, so let's now take a look at the next example. So let's read example 2 together. It says water flows at a constant rate out of a faucet. Suppose the volume of water that comes out in 3 minutes is 10.5 gallons. How many gallons of water come out of the faucet in t minutes? Okay, so let's go ahead and set up our equation. So we want to know what our rate is. And distance divided by time. Well, in this case, we're not really dealing with distance. We're going to be dealing with volume divided by time. Okay, so the volume that comes out is 10.5 gallons over 3 minutes. So let's do our cross multiplication here. That's going to give me 3 times our volume equals 10.5 times T. So now divide both sides by 3, and you get 3.5 T. So in other words, for every minute, 3.5 gallon comes out of the faucet. So that enables us to now create a table. So let's go ahead and write our equation down here. So volume equals 3.5 T. So now we want to figure out, okay, well, how much comes out in 0 minutes? How much water comes out of our faucet? Well, if it's coming out at 3.5 gallons per minute, that's going to be 3.5 times 0 equals 0. So obviously, at 0 time, no water has come out. Let's take a look at 1 minute. 3.5 times 1 is 3.5. Go ahead and start working on the rest of the table. 3.5 times 2 is 7. So now I'm just going to go ahead and fill in the rest of the table. You can as well. So you can see that 3.5 times 4 is 14 gallons. So now let's put this on a graph. And again, maybe you'll see a little bit of a pattern, or at least one major observation about writing these tables onto the graph. So again, at 0 time, how much water has come out? Well, 0 gallons. So that's going to be 0, 0. Okay. Put that right there in the graph. Now after 1 minute, there is 3.5 gallons. So it's going to be right between 3 and a 4 at 1 minute. At 2 minutes, 7 gallons, so go across to 2 minutes along the x-axis, all the way up to 7. 3 minutes, 10.5, so that's going to be right between 10 and 11. And 4 minutes at 14. So again, at this time, don't connect the dots, but take a look at them for a second. Just maybe you can make an observation that that maybe can help with future predictions. Okay, so let's take a look at our next example. Okay, so in the first exercise, Juan types at a constant rate. He can type a full page of text in 3.5 minutes, or 3.5 minutes. We want to know how many pages P Juan can type after T minutes. Write the linear equation in two variables that represents the number of pages Juan types in any given time interval. Okay, so we want to find, again, the constant rate. So we know that the amount of pages over time will give us a rate. And if you're not sure how to set that up, hopefully you've caught on to the fact that time generally goes in the denominator. And the other item, when you're talking about distance, whether you're talking about area, the number of pages is going to go in the numerator. Just put time in the denominator. That should be a good way to set it up. So we know we want to set that equal to 1 page over 3.5 minutes. So now do your cross multiplication, and you're going to solve for P. So 3.5p equals 1 over t. I'm sorry, 1 times t. So now all you have to do to get p by itself is to divide both sides by 3.5. So therefore p equals 1 over 3.5 t. So there we can see that he does 1 divided by 3.5 pages per minute. So let's take a look at our table and first put in our equation here. So P equals 1 over 3.5 times T. So if T is 0, that's going to be 1 over 3.5 times 0. So I'm running out of space here, so P equals 1 over 3.5 times 0 is just 0. So now take the next couple minutes and fill the rest of this in, because I don't have a whole lot of space here. You can write it in as I write it in. So do your best to try to fit it in there. So next one. And please use your calculator. So in your calculator, you're going to enter 1 over 3.5 as a fraction. Then you're going to multiply it times 5. And when you do that, you get 1.4. Okay, so go ahead and you're going to fill in the rest. You're going to multiply it by 10. Use your calculator. You're going to multiply it by 15. Use your calculator. And then you're going to multiply it by 20. Please use your calculator. So that's going to be 2.9, 4.3, and 5.7. Okay, so now what we're going to do is take a minute or so and plot these points on the graph. So again, at 0 minutes, we have typed 0 pages. So try your best to put a dot at 0, 0 there. So after 5 minutes, we have 1.4 pages typed. So come over here to 5 minutes, which is right here. Go up to 1.4, which is right in between 1 and 2. So put a dot as best you can there. After 10 minutes, about 2.9 pages typed. So 10 minutes is over here. Go up to 2.9, that's about there. And 15 minutes, 15 up to 4.3. And finally 20 minutes here's 20 minutes out here at about 5.7, which is pretty close to 6. So again, the beauty of the graph is we're able to predict how many pages typed based on the graph we've seen. So for example, let's just say I want to know, well, after 13 minutes, how many pages do you think he has typed? We can kind of predict based on what you kind of see here, that in 13 minutes, probably super close to 4 pages typed. Or if I wanted to predict, okay, in 3 minutes, how many pages do you think he had typed? Well, come over here to 3 minutes. Go on up to where you think it would be. Right around 1 page is typed. And you could do that in another way. You could say, all right, well, how long would it take him to type 5 pages? Well, here's 5 pages. Come on over here to where you think it might be. Probably somewhere in this range. And that's going to be about 18 minutes to type 5 pages. So we're able to make these predictions based on our graph and the data that's on the graph. So that's why graphs are very advantageous. Okay, take a look at the next exercise. dealing with Emily. So Emily paints at a constant rate. Again, you'll notice that each one of these starts with the fact that we're dealing with a constant rate, so the rate's not changing. She can paint 32 square feet in 5 minutes. What area A in square feet can she paint in T minutes? So it's very similar to the last several problems that we've done. We want to set up an equation from a ratio. So again, our first ratio is constant rate equals. Now again, if you're not sure what to put on top or what to put on the bottom, put time on the bottom. So time goes on the bottom, the amount of area we can paint goes on top. Go ahead and fill the numbers. That's 32 square feet over the time, which is 5 minutes. So do your cross multiplication. So 5A equals 32T. And we're going to solve for A. So divide both sides by 5. So area equals 32 divided by 5 times T. And again, you'll notice that we're solving for the variable that's not time. Whether it's distance, whether it's area, whether it's volume, we're trying to solve for that item instead of time. We're leaving time to have the coefficient. So just another tip to keep in mind as you work on these equations. So let's go ahead and fill in the table here. And to make things a little bit easier, we're going to make this become area equals 6.5 T. I'm sorry, 6.4 T. So please write in here area equals 6.4 T. So go ahead and fill in the rest of this table. Go ahead and hit pause. Fill yours in just like we did in the previous 3 problems. And then when you're ready, go ahead and hit record. Or I'm sorry, go ahead and hit play. Okay, so go ahead and check your answers with mine. Again, you're just substituting in different values for T. So the first one would be 6.4 times 0. That's why I got 0. The next one would be 6.4 times 1, which is 6.4, and so on. Okay, so just like we've done in the previous 3 problems, go ahead and place these on the graph. Go ahead and hit pause. I'm going to do that while you do it as well. Okay, so take a look at the graph that I have. Again, I plotted all the points at 0 minutes, 1 minute, 2 minutes, 3 minutes, and 4 minutes. So now look at question D. It says, about how many square feet can Emily paint in 2.5 minutes? Well, again, because we have a graph, we can now predict. So what you're going to do is come over to the 2.5 minute mark, which is right between the 2 and the 3. And you're just going to go up until you think it would fall between the 2 minute and 3 minute mark. So it looks like somewhere right in here. So I would predict anywhere between 15 and 16 square feet. Okay, because that's where it would fall in the graph. That's where we can predict at 2.5 minutes it would fall between around the 15 to 16 square feet mark. Okay, and finally let's take a look at the last exercise. So go ahead and try this problem involving Joseph and walking at a constant rate. See if you can set this one up all on your own. You can look at the previous couple examples. Again, if you're not sure where items go, just remember that time is going to go in your denominator. So that is a good place to start. So go ahead and take the next 4 or 5 minutes to come up with the equation, then part B, fill in the table, then part C, fill in the graph, and then try to predict using the graph to answer part D. So go ahead and hit pause, and when you're done, you can go ahead and hit play again, and you can check your work with mine. Okay, so hopefully you're able to compare your results with mine. And again, take a look at your graph. Question D now says Joseph Friend lives 4 miles away from about how long would it take Joseph to walk to his friend's house. So again, find 4 on the distance part of the graph, and then just kind of come over into where you think it would fall between the dots on the graph. So my prediction would be somewhere around 40 minutes. Give or take. If you had 42 minutes, that's fine. If you had like 39 minutes, that's fine. Just somewhere in that ballpark would be an appropriate answer. Okay? Just to kind of review a little bit from today's lesson, just know that these type of constant rate problems can be involved when you're talking about painting a house, when you're talking about mowing a lawn, typing, walking, or even water flow. Again, when in doubt, put time in your denominator when setting up these ratios or proportions to find out your equation. Okay? And to write these equations in 2 variables, just set up a proportion, do your cross multiplication, and solve for the item other than the time, as a little helpful reminder. And don't forget to graph the results. And the graph is very useful because it enables us to make predictions based on items that we don't know. In other words, we can predict how much time it takes her to do 8 miles. Or we can predict in 80 minutes how far did they go by using the graph. So the graph is very useful. Okay, so please listen to your teacher's instructions for your homework over the next couple of days. And again, on the homework, if you're not quite sure what to do, please refer back to this video at any time. All right, good luck, and we'll see you out there.